5. Okay, I've got it open.
Okay. So it looks like it says, find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25.
So the margin of error is just 2 times, I mean, it's Z star times the sigma over the square root of n, right? Is that right? M is equal. So we're going to do 1.645 times 50 divided by the square root of 25. Is that what you're getting?
Wait, sorry, say that one more time.
So it's 1.645 because that's the Z score for 90%, right?
Oh.
Isn't M equal to Z score times sigma divided by N?
Yeah.
Is that right?
Yeah. Sorry. No, I just put 90 right there because I was simplifying it. Okay, yeah. 1.645 and then 50 over square root of 25. Yeah.
So 1645.
Yep.
Okay. Which of the following statements are true? Sigma squared is an interval estimator of X bar. X bar is a point estimator of mu. Mu is a point estimator of X bar. Sigma is interval estimator for sigma squared. Isn't it X bar is a point estimator for mu?
Yeah, that's what I have.
Okay.
All right, Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation, 113. She collects a simple random sample of n equals 64 and computes x bar equals 526. Use this information. What is the point estimate for the true GMAT score?
Isn't that 526? Because
Right, yeah, because it's a point estimate for mu.
yeah.
Okay, yeah.
So sigma is a population parameter. Okay, so it's 526. Okay, what is the margin of error for the 95% confidence interval for the true GMAT score? So that's where we're finding M is going to be 95% is 1.96. So that's the Z times 113 divided by the square root of 64. Is that right?
Yeah.
Okay. That's 8. 27.685. And what does the margin of error mean again? What's this number telling me?
Just that basically if you're looking at like a poll taken online, and let's say that let's say that 80% approve, or I guess that's whatever, 80% approve of how this guy is doing things. Well, the margin of error is basically saying, you know what, we can be off by a few degrees. So let's say the margin of error is 5. So
the range is going to kind of be in between these two margins.
yeah.
So would we add the margin to X bar? So is that where it comes into like plus or minus? Kind of gives us the range.
That's what I believe so. Yeah.
Okay. Okay.
Oh, okay, yeah, because then it's how confident we are that we're actually dealing with the right thing. So the confidence interval.
Okay, that's right. And it gives us those two numbers that are kind of the range. Okay, I'm getting it.
Yeah.
All right. 7, what is the lower limit of this confidence interval? So then we'd subtract this number from 526, right?
Yeah. And did you get 3.461? So you got?
Say what?
Did you get 3.461 for
Question 6?
yeah.
No, I got 27.865.
Oh crap, wait. I was way off then.
Did you do 1.96
Uh-huh.
times 113 divided by the square root of 64?
Yeah, let me do it again.
Divided by 64 square root equals times, yeah, 27.685.
Yep. Yeah.
Okay. So now we're going to subtract that from the sample mean, which is 526. Oh, what'd I do? I didn't do that, obviously. So 498, 315.315.
Yep. That's what I got.
Okay. Now, what's the upper limit? So we add it to it. So 553.685.
Yep.
So what happens to the width of, sorry, it's your turn to read. I keep reading.
Oh no, sorry, it's okay. I'm a little behind, I guess. And just putting down on my paper and then not putting it down on the computer. Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
So if the sample size is increased, the width of the confidence interval will decrease.
Okay, that makes sense.
What I have in my notes.
Right, because the more people that we're actually interviewing, the closer it gets to the real thing. So it's not going to be a huge range.
Okay.
Or I guess not a huge range, but our
So
margin is not
basically, like, it's gonna, I guess if I think of in standard deviations kind of as those measurements away from the mean, this is kind of saying if we increase our sample size, it's not the standard deviation, but it's these confidence numbers, and those numbers get closer towards the actual mean.
right. Yeah.
Okay, so that kind of moves us along the number line towards the zero, I guess, in my mind, saying.
No, right.
As long as I have that correctly in my thinking.
All right. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
Doesn't that widen the gap? Because like if you think of the bell curve, it gives you more blue space, so it would broaden. Is that the right thinking?
You know what? I really don't know. I have no idea.
Okay, here's my notes. If the confidence level increases, say from 95% to 99%, the larger z-score, so that because that which gives us a larger z-score. Therefore, the margin of error will increase and we'll have a wider confidence interval. So I think so if you think of the bell curve and where that 95% would be, the curve is narrower, the points are closer together, but if we broaden that to 99, that's almost the whole curve, so it's going to give us a larger confidence interval.
Okay. That makes sense.
But even though the confidence interval is larger, it doesn't mean that's only telling us that the mean is the true mean is actually going to be within that area. It doesn't mean we're actually closer to finding the true mean. And I think that's where it kind of gets confusing to me.
No, yeah.
Did that make sense or no?
No, yeah. Yeah, I'm following.
Okay. Sometimes I talk myself into think, I don't know, in circles, I guess, and then I wonder, do I really understand what I'm doing? All right. 11. Bright Bulb Light Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, and they want a 95% confidence with a margin of error. So M is going to equal 50. What sample size do they need? So this is where they kind of reverse the formula around. So we're finding N.
Right.
And so N is going to be equal to the Z star, which 95% is going to be 1.96 times sigma, so times 400, divided by M, which is 50, and then all of that is squared.
Oh wait, no, I thought it was 400 over the square root of n, and all that equals m. Is that what?
Okay, but we know what M is. We don't know what N is.
I get what you're saying. You just
And so
scrambled it around so that
we could plug it into the formula where M equals the Z with the square root, but then they gave us where they switched it out and solved for N. So they gave us a formula for that.
Oh, that's what. Okay, that's what that was. Okay. Now
So
it's making
mathematically,
sense.
we could put it back in, we could put it in the same formula we just used for the last problem. And then we'd have to kind of
No, right. Just
solve it,
get
but
it
so they
back
give us
to
a formula.
what they made it. Yeah, I
So
gotcha.
1.96 times 400 divided by 50, and then square that. And that should give us n. So n is, did you get something yet?
Plugging it in right now.
Gotcha.
Okay, I got a really small number.
Okay, try again. I got 245. 1.96 times 400
Oh,
divided by 50,
yep.
and then square that. And I got 245.86.
No, yeah, I just read it wrong.
And then we round to the whole number. So it's 246.
Yep, that's what I got. Okay. The mean salary of actuaries is $100,000, and the standard deviation is $36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with level of significance 0.05 and the null hypothesis equal to 100,000, alternative hypothesis not equal to 100,000. You collect a simple random sample of n equals 36 women's salaries and find that X bar, or the sample mean, is 111,000. What is the lower limit of this 95% confidence interval?
So this is where we're going to solve for m, right? The formula where m equals, because the margin of error gives us the, is that right?
Oh, I thought it was the one where we're doing the lower one.
To do lower, don't we first have to find m, the margin of error, and then we add or subtract that from the,
Oh, right. Yeah. Right.
is that right?
Yeah. I was just kind of like skipping that step. But yeah, I think we're saying the same thing.
Oops. Did you shut the door? Whoa. What did you get?
Got 99,001.
I got 11,000. So how did you figure this one out? Wait. I didn't subtract. I just solved for m. Hello. And then I need to subtract m from that to get my lower limit, right?
Yeah, exactly.
So 1, 2, 3, 1, 2, 3, minus 12998. So you got 99,001.533.
Right, and then that's just going to round to 2 because it's the nearest whole number.
Okay, thank you.
And then for the upper, we just do the same thing but add it, right?
Right.
What did you get for that one?
Nope. Oh, sorry. Give me a second. I hit the wrong number. Plus 1199. 122,998. So that'd be 999.
Yeah, I think so.
122, comma 999. Right?
Okay, there
Are
are
you good with
3
that?
requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample is drawn from the population, sigma is known, sample mean is normally distributed, all of the above.
So a simple random sample is 1. The sample size is large. No, X bar is normally distributed, sorry. And then sigma is assumed, so all of the above.
Yeah.
Alrighty. And it is submitted. And the results are waiting.
Huh, it looks like we got 12 and 13 wrong.
Are those the ones we just computed?
Yeah.
Yep. I got 100.
Oh, you did?
You didn't get 100%?
Uh-uh.
Okay, so for 12, I have 99,002. Did you put a comma?
Well, I didn't, but it says that, like, because I think it does it automatically, because it says my answer is 99, comma 002.
Okay. And then 13, I got 122, comma 999.
And you got those points?
Yeah, I got 100.
What the heck? That is so weird. That's what I have.
Take a
I'll have to,
picture?
yeah, I'll have to email her.
Yeah.
That's so funny. It doesn't like me.
So, yeah, that is weird. And that's kind of weird because those 2 questions are only worth a half a point on my,
Right.
Is that what it says for you?
Yeah.
All the rest are 1 point? Okay. Did you record this session?
Yep.
Okay, we're good. All right, any other questions?
No, I think I'm good.
All right, well then I'll see you Thursday.
All right. See you, Christy.
Thanks.
Thanks.
Bye.
Bye.